All right, so we're talking about graphing points and planes in 3 dimensions. So before we graph points in 2 dimensions and we had an ordered pair x and y, and the first number told us how far to the right or left we went. The second number told us how far up and down we went. Now in 3 dimensions we have what's called an ordered triple, x, y, and z. And the first number is going to tell us how far forward or backwards we go. The second number is going to tell us how far right or left we go. And the third number is going to tell us how far up and down we go. And this is just summarizing what we just said. Now, if x is positive, we're going to move forward. If x is negative, we're going to move backwards. If y is positive, we're going to move to the right. If y is negative, we're going to move to the left. If z is positive, we're going to move up. And if z is negative, we're going to move down. So for example, I have an ordered triple, 3, -2, -4. So I want to be able to plot this on the graph. Now we always start at the origin, and the origin is exactly the same as it is in 2 dimensions. It's right here in the middle. And the first number tells us how far we move forward or backwards. It's positive, so I'm going to move forward 3 spaces. Second number is negative, so I move to the left 2 spaces. And the third number is negative, so I move down 4 spaces. So this is my new point, 3, -2, -4. Now, just like in 2 dimensions, we have x-intercepts, y-intercepts, and now we also have z-intercepts. And the analog is pretty much the same. So the x-intercepts occur when y is 0 and z is 0. So our order triple is going to be just some number x, comma 0, comma 0. The y-intercept happens when x is 0 and z is 0. So our order triple is going to be 0, some number y, and 0. And the z-intercept occurs when x is 0 and y is 0. So our order triple is going to be 0, 0, and some number z. Okay? Now that we know how to find the x, y, and z intercepts, we can graph planes in 3D. So planes are just like a giant sheet of paper that extends off in all directions forever. So the first step is to find the x, y, and z intercepts. You have to find all 3. And then you have to draw the traces, which are just the lines that contain each pair of these intercepts. And then finally, shade in the enclosed region. This is going to model the plane. So, for example, I want to graph the plane 2x plus 3y plus z is equal to 4. So first we have to find all 3 intercepts, the x, y, and z. So again, the x-intercept happens when y is 0 and z is 0. So what I'm going to do is take my original equation, and everywhere I see a y and everywhere I see a z, I'm going to plug in a 0. So that's what I did here. And simplify, so I end up with 2x is equal to 4. And when we divide both sides by 2, we get x is equal to 2. So my order triple for the x-intercept is 2, 0, 0. My y-intercept follows the same idea. It occurs when x is 0 and z is 0. So I plug into the original equation and simplify. So I get 3y is equal to 4, divide both sides by 3, and I find that y is equal to 4/3. So my order triple for the y-intercept is 0, 4/3, 0. And then finally for the z-intercept, we know from our definition we just had that it happens when x is 0 and y is 0. So again, plug into the original equation. Everywhere you see an x, you're going to put a 0. Everywhere you see a y, we're plugging in a 0. And simplifying, so we end up with z is equal to 4. So my order triple for the z-intercept is 0, 0, 4. Now we graph all 3 of our intercepts, my x-intercept, my y-intercept, and my z-intercept, and we draw the traces, which are simply the lines containing each pair of these intercepts. And we shade the enclosed region, which is this triangular region. That triangular region represents the plane that we just were looking at. So my question for you is, based on what we just learned, how would you graph the plane modeled by the equation x plus y plus z is equal to 5?